Hello everyone, welcome to today's class. This is Teacher Simon taking you through IGCSE Core Mathematics paper 0580/32 for May June 2025, and this is part 2 for questions 13 to 24. Question 13 part A, we have 2EF20 and they are saying that a linear sequence, this is the one that has gotten the common difference. So you add the same thing here, and then there. You get it? A linear sequence has the first term 2 and the fourth term 20. Then the term-to-term rule for this sequence is add k. Work out the values of E, F, and K. Okay, so we have 2 E, F, 20. So we are adding K every now and then. Are we there? So meaning I'm going to have 2 plus K plus K plus K. It will give us 20. Not so? There are 3 K's in here to come to the 20. Now that means we are having here 3K, then plus 2 is equal to 20. Then our K is going to be 20 minus 2, which is 18, divided by 3, you get a 6. So our K is a 6. Okay, then what is E? E is going to be equal to, we know that 2 plus K is equal to E. So don't you think E is equal to 2 plus 6? That would be 8, not so? And then also we have F, okay, plus K will give us 20. That means F will be equal to 20 minus K, which K is 6, and this is 14. So F has to be 14, and then E has to be 8. Okay, then part B, these are the first 4 terms of another sequence. We can see here that they are subtracting 2. This one is decreasing by 2 every now and then. Even this one is a linear sequence. So the nth term is given by A, then plus n minus 1 d. This is the general expression for the nth term of a linear sequence, where A here is the first term, okay, where A is the first term, and then D here is what we call the common difference or the term-to-term rule. So the term-to-term rule, they are subtracting a 2. So our first term is a 9. You just substitute in here. This is n minus 1. Now, I've always seen students writing, like this is minus 2, then they put minus 2 here. This one looks like another operation. So it's better you write times negative 2. You see that? Then open the brackets. This will be 9. Negative 2 times n, you get minus 2n. And then negative 1 times negative 2, you get a positive 2, right? Then 9 plus 2, that one gives us 11. And then minus the 2n. So nth term is always an expression, okay? Then question 14, part A, P is equal to 6A plus 5B. Find the value of B when P is 25 and A is 3. So P is 25. It's just a matter of substitution. This is 6, then A is 3, then plus 5B. So this is 18, right? So we shall have 25, then you bring the 18, let it cross the equal signs, it becomes a negative. So that will be 18, which is equal to 5B. And what do we get from here? 25 minus 18, that one will be a 7. 7, okay, is equal to 5B. Then we shall divide all through by 5. And our B becomes 7 over 5 is the same as 1.4. As simple as that. Then part B, make it the subject of the formula in here. So we undo operations here. And when we undo operations, addition is undone by what? Subtraction. Even subtraction is undone by addition. And then multiplication and division, they each undo each other, okay? Then we are making T the subject. So first take away the W from here. When I take it away, because it is addition, we undo it with a subtraction. In other words, when it crosses the equal signs, it becomes a what? A minus. So we shall have W then minus Y, which is equal to KT. And now you can see that this is a multiplication. So to undo the multiplication, we are having a what? A division. Divide all through by K. And here you also divide it through, so it disappears. And therefore your K, your T is going to be W minus Y out of K. As simple as that. Question 15. The equation of a line is Y is equal to minus X minus 5X then plus 7. Part A, write down the gradient of this line. Now the general equation of a line is Y, which is equal to mx plus c. And the coefficient of x here is the one we call the gradient. Okay. And then the c here is the y-intercept. That is where the line cuts y-axis. Okay. Now, when you check what we are having here, this coefficient of x here is negative 5. That means our gradient is negative what? 5. Find the coordinates of the point where the line crosses x-axis, y-axis. On y-axis, you should know that x is equal to what? 0. So you'll have y now equal to negative 5 times 0, that is a 0, then plus 7, you'll get a 7. So meaning the x coordinate is 0, and then the y coordinate is a 7. That is actually the y-intercept. So the 7 that you have here is the y coordinate, and then 0 is the x coordinate on y-axis. Question 16, part A. Sam spends $187 on electricity and gas. The ratio, electricity to gas, is 8 to 3. Work out how much Sam spends on electricity. So electricity here, the total ratio is going to be 8 plus the 3, right? But 8 belongs to the electricity. It corresponds to the electricity. So we are going to have 8, then out of the total, 8 plus 3, then times the 187. Then what do we get? 8 out of 11, then times 187. That is $136. Then part B, Jai spends $180 on electricity and $150 on gas. Write down the ratio electricity to gas in the simplest form. So we shall have 180 here, then 150. First, I'll divide by 10, right? By 10. Then this one will give me what? 18. And then here, 15. Now here I can divide all through by 3, not so? So in other words, altogether, I can divide through by 10 times 3, that is 30. So 18 divided by 3, you will get a 6. And then 15 divided by 3, you will get a what? You'll get a 5. As simple as that. Then C, they are saying Kat spends money on electricity and gas in this ratio here, E to gas. And they are saying that write down an expression in terms of E and G for the fraction she spends on gas. Okay. Now, when we use ratios here, okay, ratios, we can also convert them to fractions. Fraction she spends on the gas. Now, for gas, remember, we are going to have gas belongs to G here, okay? So we shall say G, then out of the total ratio, E plus G. You see that? That will be now the fraction for the gas. Just like we did here when we were finding electricity. 8, then divide by the total, then times, if you know the total, to get the amount. So I'll just get this one here, and then I shift it, and then I put it here. That is my answer there. Question 17. Ricky invests $6,000 for 5 years at a rate of 9% per year compound interest. And they're saying that we calculate the total interest earned during the 5 years. Now, amount using this compound interest, it is going to be the principal into 1 plus r out of 100, okay, to the power of t. You can put n because that is the duration. And this one here, we also know that a is equal to that amount is equal to the principal, then plus the what? The interest. So we shall say 6,000 divided by 5 years. That is 100. Then plus the what? 100. Then times 100. That is 100. Then 5 years. That is 5 years. Then plus the what? 100. Then times 100. That is 100. Then plus the what? 100. Then times 100. That is 100. Then plus the what? 100. Then times 100. That is 100. Then plus the what? 100. Then times 100. That is 100. Then plus the what? 100. Then times 100. That is 100. Then plus the what? 100. Then times 100. That is 100. Then plus the what? 100. Then times 100. That is 100. Then plus the what? 100. Then times 100. That is 100. Then plus the what? 100. Then times 100. That is 100. Then plus the what? 100. Then times 100. That is 100. Then plus the what? 100. Then times 100. That is 100. Then plus the what? 100 the interest. So since they want the interest, now I've always seen this mistake here. Students write, this is compound interest, then it's equal to this. No, this is the amount, the total amount, okay, that we get at the end of that period. But that amount has gotten the what? The interest in it. So for us to get the interest, then it is going to be equal to amount. You take the principal this side, so it becomes a negative, so minus the principal. So what is going to be our amount? I'm going to substitute in here. So that is 6,000, then into 1 plus R is 9%, and then our T is 5. Then we shall subtract 6,000, okay? Then what do we get? And since this one is amount of money, usually we write our answers to 2 decimal places, okay, when it comes to money. So what do we get altogether here? 6,000, then times, this will be 1.09 inside the brackets, then to the power of 5, and then we subtract 6,000. So we get 3231, then 0.74. 3231.74. Or you can write this onto 3 significant figures and you write 32, then 30. But who can accept to lose his or her dollar? So just write with 2 decimal places here, okay? Question 18. A factory produces brass at a rate of 172 kilograms per hour, but A convert this rate into grams per second. So we have 172 kilograms. Then we are dividing it by 1 hour, okay? Now, we are converting the kilograms to grams, and you know that 1 kilogram is equivalent to how many grams? 1,000. And then 1 hour is equivalent to how many seconds? It is 60, because 1 hour has 60 minutes, and each minute is equivalent to 60 seconds. So that is 3600, right? Then after this one here, we can now say if I'm converting the kilograms to grams, I will multiply. So wherever there is kilograms, then I'll put 1,000 grams. You see that? And then wherever there is an hour, I'll put these are seconds, 3,600 seconds. So what do we get altogether simplified? 172,000 divided by 3600. This one is 430 out of 9. You can leave it like that, or you can write it as a what? We call that a mixed number. So getting back to what it was, okay, you press shift, then this button, S to D. So we have S, then to D, okay? That one there can convert for you from decimals to fractions, from fractions to decimals, then from also fractions to mixed numbers. So shift and then that S to D. So that is 47, then 7 over 9. This one is actually 0.7 recurring. Okay, so I can leave it there like that. Then part B, the rate is increased to 176 kilograms per hour. Calculate the percentage increase in the rate. So what we are going to do here, we are going to get the increase, we divide by the original value, then times 100, okay? So the increase is going to be 176 minus the original value here, then divide by the original value, 172, then times 100. So what do we get altogether here? 176 minus 172, then we divide by 172, pardon me there, then times 100. We get 100 over 43. Maybe to 3 significant figures we can write 2.33. 2.33%. 3 significant what? Figures. Okay, then even here to 3 significant figures, I could write 47.8, Because remember, this is 7, 7, 7, 7, 7 recurring. You get it? That is that. 2, 3 significant what? Figures. Okay. Question 19, part A. Write this number in standard form. So we shift the decimal point up to here. Remember, when we are writing to standard form, we have a times 10 to power n, and this a is ranging from 1 to less than 10. Okay, we have 9 point something. You don't write 10 point something because those will be two significant figures. In other words, if you have a decimal point here, then you must have one significant figure here on the left of the decimal point. You see that? So we move. This is 1, 2, 3, 4, 5, 6, 7, 8. So I will have 3, then 0.47 times 10 to power 8, because I've moved 8 to the right. But this one has to be a minus because you moved the decimal point from the left side. Are we there? Okay. And part B, calculate this one here. We give the answer in standard form. So 3 times 10 to the power of 4 times 5, then times 10 to the power of 6. We shall get 3. First multiply it with the 5. Okay. And then, what else? Then times, this will be 10 to the power of 4 times 10 to the power of 6. This one will give us 15. And then 15. Here, since the bases are the same and we are multiplying, then we shall add the what? The powers. You see that? But now, if you write 15 times 10 to the power of 10, this is not the standard form. Okay? We said that you must have one significant figure here on the left of the decimal point, and these ones are 2. So we need to shift the decimal place, and then we bring it here. So we have to have 1.5, then times 10 to power 1, because I moved this one to the left, from the right to the left. Okay, 1 place, then times 10 to the power of 10. So that means here we shall have 15, then times 10, you have 1 plus the 10, which gives you 11. So we shall have 1.5, then times 10 to the power of 11. As simple as that. Question 20, solve part A, x plus 3 is equal to 3. Of course, the x here is going to be 3 minus 3. So when you take this on this side, it becomes a minus. So that means your x is going to be 0. And then B, we shall cross multiply. To undo division, we multiply, right? So we shall have 5y, which is equal to 3 times 8. And therefore y, to undo the multiplication, we shall do division, right? So this will be 24, then out of 5. So you can write your answer here as 24 over 5, or you can write 4, then point what? 4 over 5, that is 0.8, so 4.8, just like that. Or I can write this one as 4 whole number, then 4 over 5. Many ways to write the answer. But in the exam, don't write all of this, just write one answer, okay? Then let's come to question 21. This one is coming from indices. Simplify part A, w power 3, then power 10. This one is going to be w power 3, then times 10. Because here you will have w power 3. You have another w power 3. You have another w power 3. You have another w power 3 times w power 3. Then times, these are 5, not so? If they are 5, let me just duplicate them to make 10, not so? Then times that, so they are 10. So don't you think you're going to have w, then 3 plus 3 plus 3, 10 times. So that's why we multiply these numbers. You see that? So this one is going to be w power 30. Okay? Then here, I'll get the t's and I multiply them. So t power 6, then times t power 3. I just rearrange. This is all multiplication. You just switch them. Okay? Then times v, then to the power of 7, times v to the power of negative 2. Since this is multiplication, we add the powers. So this will be t, then 6 plus 3. And then here, you have v, 7 plus negative 2. So 6 plus 3, that is a 9. So we shall have t to the power of 9. And then v here, 7 plus negative 2, that will be positive 5. So that will be our answer there. Question 22. In this question, all lengths are in centimeters. This is a right angled triangle. And wherever you see a right angled triangle, then you can use SOHCAHTOA and also the Pythagoras theorem if only lengths are involved. Okay. If an angle is involved, then we can use the SOHCAHTOA. But then here they are saying that part A, write down an expression in terms of x for the perimeter of the triangle and write your answer in the simplest form. Now we know that for perimeter, we sum up all the lengths, okay, around the shape. So perimeter is going to be 2x minus 5. Then we add 4x minus 9. We also add 2x plus 2. Now 2x plus 4x, that is 6x plus 2x, that will be 8x. So we shall have here 8x. And then negative 5 minus 9, that will be minus 14, plus 2, that will be minus 12. So minus 12, and that is our answer. And then part B, the perimeter of the triangle is 40 centimeters. Work out the value of x. So what I've gotten here as 8x minus 12, I'll just equate it to the 40. Take this one this side. It will add to the 40 because this one is a minus, right? So this one will be 40, then plus 12. And this is 8x, which is equal to 52. So meaning our x is going to be 52, then divide by 8. As a decimal, what does this one give us? 52 divided by 8. That one gives us 6.5. So that is 6.5 centimeters. And then part C, work out the area of the triangle. Area of triangle. Area of triangle, you know that it is a half times base, then times the perpendicular height. Not so? Okay. So this will be a half times the base. The base is 2x plus 2. So we have 2, then x is 6.5, then plus 2. And then times the height, which is actually 2x minus 5. 2x minus 5. So what do we have in here? We are going to have a half, then times, this is 13 plus 2. That one gives us a 15. And again, this is 13 minus 5, that is 8, not so? Times 8. Then this 2 goes here 4 times, then 15 times 4. That one gives us what? A 60. So our answer here becomes 60 centimeters squared. Question 23. A sphere has radius 8 centimeters. Okay, so this is the sphere. A sphere, just look at a ball, as simple as that. The radius is 8 centimeters. That is our sphere. And then we have the cone. Cone looks like this. The cone here has a radius of 8 centimeters. Okay. And then the height is h. This height here is perpendicular. The sphere and the cone have the same volume. So they are saying that volume of sphere is equal to the volume of the cone. Okay, volume of the sphere, volume of the sphere and volume of the cone, they are given in the list of formulae, which is page 2. Okay, so when you come to page 2, volume of the sphere, we can go down here, volume of the cone. So they are here, volume of the cone and volume of the sphere. So volume of the cone is a third volume of the cylinder, not so? As a third pi r squared h, and then this is 4 over 3 pi r cubed. We have seen that volume of the sphere is 4 pi r cubed, then over 3. Then volume of the cone is a third, then pi r squared h. Okay, now this 3 will cancel with this one, then the pi will also cancel with that pi. So meaning we have 4r cubed, then which is equal to r squared h. And by the way, these two have the same radius. So that's why I've left this one to be r and then r. Otherwise, if the radii were different, then I would have put maybe this one as small r and then this one as capital R. You see that? Okay. Now I can also divide all through by r squared so that this one goes, and then you have here 4r, which is equal to what? H. So therefore our h is going to be equal to 4 times the r, which r is what? 8. So 4 times 8, that is 32. As simple as that. Then lastly, question 24. The diagram shows two right-angled triangles. Calculate the value of D. Now you can see for any right-angled triangle, I told you you can use SOHCAHTOA or Pythagoras what? Theorem. So D here is a length. Now, using this triangle ADB, I can get this length. Now, since there is an angle here, so of course, now here I have a length, and then a length. That means I can use Pythagoras theorem. Are we there? Then when I come to triangle BCD, I have an angle involved. Then there is a length here and then a length. So here I can use SOHCAHTOA. Are we there? So using Pythagoras theorem on triangle ABD, we shall have 10.8 squared, then plus BD squared, then this one will be equal to 14.7 what? Squared. So that means BD will be equal to, so you'll get 14.7 squared. Take this one, this other side, it will become a minus, right? Now that is BD squared, but then I need BD, so I'll take the square root. Okay, so what do we get here? Square root 14.7 squared minus 10.8 squared. This one is giving us that ugly answer there. Okay, but I'm going to just leave the what? To leave it exact. So what I will do is to say 14.7 squared, okay, then minus the 10.8 squared. So I'll write root of 99.45, square root of 99.45. Get used to using what we call exact values. Now I'm going to use SOHCAHTOA. So using now SOHCAHTOA, this acronym helps us to get the trigonometric ratios on the right angle triangle. So the trigonometric ratios that I mean are sine, cosine, and tangent. Okay, so using SOHCAHTOA on triangle, which triangle? BCD. Okay, BCD. Even this one, I think we can just put that. Now, we have square root of 99.45. So relative to this angle here, this side which is far away is the opposite side. Are we there? Opposite side. Then the side that is perpendicular to the opposite is what we call the adjacent side. And then this is the hypotenuse. So we are looking for opposite, which is O, then adjacent. Adjacent is which one? Opposite and adjacent. So we shall take the TOA. You see that? So tan of the angle 52 then is equal to the opposite, which is D, divided by the adjacent, which is root of what? 99.45. That means for us to get D, we shall just cross multiply. So meaning D is going to be equal to the square root of 99.45, then times the tan of 52 degrees. And then what is our answer to three significant figures? Now you make sure that your calculator is in degrees, okay? So you can see a D on my pop-up display. So I'll just put a square root of 45, then times the tan for term on 52. The answer becomes 12.8 to three significant figures. 12.8, okay? Three significant figures. Now, if your calculator is not in degrees, you're going to get a different answer. That is why I'm always saying in your O-level here, always first check the mode of your calculator, because you don't use radians, neither do you use gradians. So when we check our calculator here, remember the answer we have gotten here, that is when the calculator is in the degree mode. But if I change it to radian mode, I will just press shift and then mode. Then rad is option 4, and then I put 4. Then I press equals again. It's a different answer. You see that? So the mode of your calculator is very, very important. Again, when I change to gradients and I press shift, then mode, that one will be a 5. Okay? And then I press equals again. Do you see that I'm getting another different answer? So you have to be very careful with the mode of your calculator. So first make sure that it is in radians, and then, it is in degrees, and then you get the right answer. Okay? So thank you so much for watching. This has been it for this second part of the paper. May God bless you. If you find the content very helpful, kindly like, share, and even subscribe. See you in the next videos.